Hello, and this is review 3 this is the review 3 presentation for microprocessors and interfacing, and our topic for the project is remote gardening kit using Alexa skills. So let us start off with the introduction. So I'll introduce you to the team. We have Manav Modi, Sara Kulkarni, and Parul, and myself. So this is all right. So the introduction. So as we all know, oxygen is a very important part for survival of living species, and oxygen plays a major role in all the other different processes that occur in our ecosystem. And the maintainers of this oxygen are plants. And over the past a few centuries, humans have grown greedy and we have been cutting down plants left, right, center without any proper replantation drive. So this has caused a lot of distress to our ecosystem, and this is going to be very detrimental for future generations. So why did we choose a project that was related to this? So basically, when the pandemic struck, a lot of people lost their jobs, and many other people lost their social status, or what do you say, social life, basically, because you're sitting at home, you can't go out anywhere and all that. So people started taking up hobbies. So according to an online survey, there was a 270% increase in purchases of gardening related products. So basically, we are looking at a 270% increase for people who are taking up hobbies related to gardening. So now what happens once pandemic comes to an end, maybe next year or next to next year. So whenever the pandemic comes to an end, people will have to go back to their regular jobs, and hence they will not have time to care for these plants. So they'll have to give it away, or these plants will most likely end up dying. So we thought, a remote gardening system will help such people to take care of these plants even after they go back to their regular jobs. So we designed a system that's going to be integrated with your Alexa, because Alexa has a very large ecosystem, and can be used by any person. You don't have to have any special expertise in order to use this. So the main objective of our project is to create a system that is very easy to use for people in order to take care of the plants even after they go back to their jobs and go back to their normal social life. And there is also a therapeutic reason, because plants actually help us de-stress at times. When you're extremely stressed, you'll not feel like doing anything. So gardening is one such hobby which is known as a de-stressor. So basically that's the objective of our project. So I'll hand it over to Manav to explain the methodology and everything else. So Manav.
Yeah. So Aaron, thank you for the entire giving a better perspective to the project. Now I'll take over the part where I'll explain about the software and the hardware that we have used, okay, and how we have implemented the entire project. So talking about the software, so we have used the Arduino software IDE, Sketch for Arduino IDE, Arduino IoT Cloud, and Amazon Alexa Arduino skill. So let's move on to the hardware part now. Yeah. So for the hardware, we have used Arduino MKR1010 or MKR 1000 series board. So where the reason why we have provided an option here is that because on the while we were starting this project, we had two options in front of us, but then later we focused on getting MKR 1010. Then we have LED and registers and miscellaneous connectors that we use for connecting stuff around. Let's move to the next slide. Yeah, so talking about the method, okay, so this project couldn't have been more made more simple. So the concept is very simple. The Arduino board is connected to the LAN through Wi-Fi, which every one of us has. Like the board is then using its inbuilt IoT Cloud API, and it communicates with the IoT Cloud interface. So then when the user wants something to be done, he or she speaks into the phone, and by using the Alexa app, that's it, and your task is done. Upon receiving the command, Alexa communicates with IoT Cloud, and then the IoT Cloud relays the instruction back to the board. All of this stuff happens on the back end. The user doesn't have to do anything. It's just one command and the task gets done. Arhan, next slide. Yeah. So talking about the task completion, this was the status that we had. by the end of the review 2. So we successfully procured the MKR Wi-Fi 1010 microcontroller, as we said that. So we successfully configured the board to the network, which involves running the code part, so that the connections with the cloud and the inbuilt cloud API can be done. That part was successfully executed. Then we successfully completed the Alexa integration to the board with the board, and then we demonstrated the working of the project using an LED, which was like kind of a proof of concept, where if LED turns on, it means that it is on high mode, and then it can be replicated to a number of use cases. And when it is like the LED is off, it means that it is low, and then you can switch off the stuff that you want to, like, if you that you want to control. Let's move to the next slide. Yeah. So talking about the challenges, this project wasn't easy for us, mainly due to the pandemic. So pandemic has hit us all hard, and even the project itself. So the main challenge here was in procuring the temperature sensor and the solenoid valve. So initially, the aim of the project was using these two tools and making a very market ready product, but we couldn't do that because of the non availability of these equipments. And then we stuck to using an LED to show the proof of concept, as I mentioned earlier. Now there was an issue with regards to the toggle mode of the cloud switch, explained later in the demo, which we are going to show as a video demo. And this was overcome by simplifying the code into basic iterative statements. So we essentially made the code simpler, so that the memory that it occupies and the all those different stuff that comes up with very complex code, that could be reduced. Now let's move to the next slide. So I'll also like want to focus on the conventional system that we already have, the traditional system that we already have, and something that has been new and we used in our product, in our project. So we use Alexa based IoT, and comparative to that, we also had an option to use the traditional IoT. But why didn't we use it? I'll mention that here. So Alexa based IoT, it provides access to a wide variety of devices, because you know that Amazon in itself is a big company, and Alexa is one of the products of Amazon. So it offers the wide access, like the entire ecosystem is in front of us, and you can actually control anything using this board. It's just a simple configuration that I'll show later in the app itself. So then when we move on to the traditional IoT, it's not like that, because it's like it does not have a big ecosystem. It's very niche. Okay. So it's easier to integrate with the existing devices. In the case of Amazon, as I mentioned earlier, any smart bulb or anything that has compatibility with Alexa is also compatible with our board. So that is that easy. So it's difficult to configure and set up for the novice user, because traditional IoT needs to check the compatibility requirements for each and every device with the traditional IoT. If it matches, then only the user can use it. So that's not at all very much easy for a novice user, because it includes checking up a lot of deep details before no user actually wants to do the research. They just want everything that is easily accessible. Talking about the cost, because Indians, like, they usually focus a lot on the cost. So the Amazon based IoT, Alexa based IoT, it's highly cost effective. We have It has like a lot of use cases that makes it makes the cost very less. As compared to that, the traditional IoT, it is not at all cost effective. And talking about scalability, so who doesn't want scalability? Like, if you are going to invest into something, you want that solution to scale up. So Amazon Alexa based IoT actually has that potential. Whereas with the traditional IoT, as I mentioned, it doesn't it throws out a lot of compatibility issues, and it is not at all scalable. So let's move on to the next part of the review 3.
Thank you, Manav. Now, me and Parul will be explaining the project report extensively. Moving on to the abstract of the project. So as Arohan had mentioned earlier, this project aims to make a garden care for itself with the help of electronics. This will eliminate the unnecessary obligation and also ease the gardening process. The main aim of the project is to maintain the nature of plants by continually monitoring the parameters leading to its increased life, both of the plants as well as the human beings who develop new techniques in agriculture automation to flourish and deliver its full potential. Now, this system is designed by using an ARDUINO microcontroller, which can help transform your gardening process to a smart and a dynamic one. And moving on to the literature survey. Okay, the reference links are mentioned below for the literature survey. So the very first research paper is called the voice integration on smart indoor gardens using Alexa Amazon. Now, this project was carried out to develop a smart indoor garden that utilizes a voice over integration technology using Amazon Alexa on a automatic. Oh my god, sorry. Okay. This project was carried out to develop a smart indoor garden that utilizes voice over integration technology using Amazon Alexa on a semi-automatic and a fully automatic watering system without any intervention. Then the results and the experiments that were conducted to test the functionality of the voice over integration on the smart indoor garden system in the terms of accuracy and network performance in receiving the voice over commands and the time taken to interpret the command. The second research paper is topicized as home automation with gardening system. Now, with the knowledge of the new techniques in electronics, this paper was able to make lives more comfortable. One such application of electronics is used in the home appliances controlling using Android mobile with via Bluetooth. Now, the approach that they followed in this research paper and which is explained in this project is a novel research paper and has achieved the target of the home appliances controlling using Android mobile via Bluetooth, satisfying the user needs and the requirements. The third research paper deals with an enhanced automation of garden watering based on IoT. Now, this research paper deals with the sampling speeches which are collected using computerized speech laboratory (CSL), and the results shows overall accuracy of the sentences passed and the sentences recognized at the rate of the system came to be at 91%. Next, another IoT based gardening watering system implemented using the mobile Bluetooth. Now, the fourth research paper is headed as IoT-based smart home gardening watering system using Raspberry Pi 3. And this research paper deals with the temperature sensor, a humidity sensor, soil sensor, which are connected to the peripheral interface controller, PIC microcontroller. Now, the results of this such study are displayed on the mobile device using the application as well as displaying on the LCD display, which is connected to the microcontroller. Apart from that, implementing Raspberry Pi 3 and an Android application via Wi-Fi was developed. Now, the users can monitor and control their home appliances remotely even after receiving alert signals from smart home automation system. Now, another study, which is the fifth study, is called as the agricultural knowledge management using smart voice messaging systems. Now, this research paper deals with the use of physical and human sensors in agriculture, such as Internet of Everything, where Internet of Everything is a combination of IoT and the Internet of human sensing. This smart voice messaging system in this research has three functions. Now, the user records his voice messages with the related information such as the user ID, time, and location. Second, the system stores these messages, voice and text recognized, in a database and automatically distributes them to the users who are relevant to the messages. Thirdly, the system visualizes the messages stored in the database from several viewpoints, such as user, time, location, keyboard. These functions are executed on a smartphone application on an Android operating system and a web server application on the Windows server. The results were quite impressive for this research paper. Moving on to the sixth research paper, this is headed as the Automated Hydroponic Gardening System. Now, this research paper, it deals with, they're more instrumental to commercialize hydroponic grading as hydroponic gardening as an urban agricultural method. Fully completed controller with sensors and other actuators cost below rupees 45,000. When compared to other products in the consumer market, the automated hydroponic controller is an affordable controller and a low power consuming product to the market. The seventh research paper is called the Future Gardening System Smart Home. Now, this research paper deals with, it's based on these forecasts and evaluating the results. Now, SG uses augmented reality (AR) technology to allow the users to view virtual objects superimposed on the real world. This use of the computer graphics allows the growers to understand the outcomes intuitively, while the SG records the actions. Now, moving on to the last paper, which is called the Smart Garden Monitoring System using IoT. Now, this topic deals with the implementation of smart garden system using IoT, which has been verified to a satisfactorily working by connecting different parameters of the soil to the cloud and was successfully controlled using a mobile application. Now, this system designed not only the monitors to sensor data like moisture, humidity, temperature, and ultrasonic, but also actuates other parameters like according to the, for example, if the water level in the tank is reduced to a minimum value, then the motor switch is turned on automatically to the water level of the tank reaches till the water of the tank reaches its maximum value. Okay, moving on to the introduction. Parul will be explaining the introduction.
Thank you, Sarah. As we all know how important plants are as they maintain the carbon dioxide and oxygen content in the air. And we also know that how highly they are being reduced due to urbanization. Many people during this pandemic have picked up gardening as their new hobbies. But what would happen once the pandemic comes to an end and people go back to their daily activities, which would definitely leave the lot of plants without proper care? Our project addresses this problem. Automation rules the world nowadays. It is a technique of using computers or mobile phones in monitoring and controlling the simple parameters of day to day life. The standard of our life will be nourished by the practice of using automation for simple things. Using the concept of IoT, we make sensors to communicate with each other, which are powerful in automation. The important aspect of our project model is that it saves cost and ensures safety. When people try to make planting and set up their own garden, they are always conscious to maintain in the beginning stages. But as days goes, due to lack of maintenance, the plants get destroyed. Our remote gardening kit will help people to automatically monitor the parameters and ensure maintenance of the garden. It plays a vital role and serves a good companion for the plants. So that's how our main aim for this project comes. That is to maintain the nature of plants by continuously monitoring the parameters leading to increased life for both plants and human beings. Now, coming to the proposed work, we have used the smart garden, like we'll be giving a smart garden system, and our smart garden consists of various hardware and software components. The concept is pretty simple. The Arduino board is connected to the LAN through Wi-Fi. The board, then using its inbuilt IoT Cloud API, is communicated with the IoT Cloud interface. When the user wants something to be done, he or she can speak into the phone using the Alexa app. Upon receiving the command, Alexa communicates with the IoT Cloud, and then the IoT Cloud relays the instructions to the board. Whenever the user finds need of watering the garden, a switch in the application will automate the process. This helps in maintenance of the garden. The software component that we have used in our project are Arduino Software IDE, Sketch for Arduino IDE, Arduino IoT Cloud, Amazon Alexa Arduino Skills. And the hardware components are Arduino MKR1010, 12-volt DC solenoid control valve, TMP36 Arduino temperature sensor, and other miscellaneous connectors. We have also provided the reference for the components and the schematic diagram, which is readily available in the online. Now Manav shall continue with the experiment setup.
Well, okay. So now let's move on and see like what work have like we have actually done. So this is the Alexa app that you can see on the screen. So this is actually the home screen. The screen where you'll land after opening the Amazon Alexa app. Now let's move on to the actual core of the project. So you can see here that we have these two screens. Aaron, can you slide down a little bit? Yeah. So as you can see that we have these two screens, and these are actually the part of the main part of the project. You have a garden group, and inside that we have created a lot of switches. So basically water 1, water 2, water 3, and all those things are switches. So like a switch has on off mode, similarly that concept can be drawn here as well. So if I turn on water, so then the water will be set on high in the IoT cloud, and the action will be executed in real world. And if I turn it off on the app, it will be set to low on the cloud, and the watering will stop. So you see, we have made the concept very simple. And if you don't want to go through the pain of pressing through each and every switch, we also have a solution for that. We just you can just press on or all off, and that will do the work for you. So you see that in terms of user convenience, we have tried to make it as simple as possible. Now let's move on to the next slide. Yeah. So talking about the configuration and the results. Okay.
Yes, sir. Let's now look at the configuration and results. So here we have put two pictures, the LED off state and the LED on state. So basically, as we mentioned before, we faced a few challenges in procuring the required components. So we had to make do with whatever we had at hand. So we had an LED and resistor lying around. So in order to show proof of concept, we just connected it. So if as long as power is going through, it can activate any component. So this is proof of concept here. So these are our results basically. So we successfully procured the Wi-Fi board MKR1010 microcontroller. And as we explained in our review 1 presentation, the main reason we went with the MKR series is because it has an integrated Bluetooth module and an integrated Wi-Fi module. So this does not require us to connect to an Arduino shield, which will again cost extra and also cause problems while configuring sometimes. So we successfully configured the board to the network. So basically it is a file called there's a configuration file where you enter the network SSID and password, etc., and so that you can configure the board. So once it goes onto the board, the Wi-Fi chip will automatically connect to your Wi-Fi network. So we successfully completed the Alexa integration with the board. So the Alexa integration with the board here, meaning you had to install Alexa in your phone, connect it with your Alexa account, and once that is done, you have to install the Arduino skill and log into your Arduino IoT cloud. So once that is done, it will automatically detect the board on the Wi-Fi network and connect to it. And once that is done, wherever you take your phone, your board is always connected via the Arduino IoT cloud. We also successfully demonstrated the working of the project. Below we have provided the links for review 1, review 2. In review 2, we have explained the demonstration in detail. So you can take a look at the demonstration there. So as mentioned before, we faced a few challenges. So the primary challenge was we were unable to procure the TMP36 temperature humidity sensor and also the solenoid valve primarily because due to the pandemic, a lot of the shipping was closed. So we were able to procure the MKR series board before because of availability, and that also we had to procure with a lot of difficulty. But once the pandemic started ramping up, most of the northern states started locking down, so deliveries stopped, and also Tamil Nadu locked down. So we were unable to procure the board. Unable to procure the other components other than the board. So then there was also an issue when we were coding it. We came across high levels of complexity, so we were unable to resolve the errors. So we simplified the code and tried to reduce its size, and it ended up working in our favor. So we made it into a simpler code by just improving on our iterative statements. So I'll pass on for the conclusion.
So, we have explained the whole experimental setup, results, challenges, and everything. So, coming to the conclusion, the implementation of remote garden kit using Alexa scale has been verified to satisfactorily work by connecting different parameters of the soil to the cloud and was successfully controlled remotely through a mobile application. The system design not only monitors the sensor data like moisture, humidity, temperature, and ultrasonic, but also actuates other parameters according to the requirement. For example, if the water level in tank is reduced to a minimum value, then the motor switch is turned on automatically to the water level of the tank reaches the maximum value. The initial cost and installation of this system are cheap and hence it can be implemented anywhere. With the development of sensor technology, the system can be elevated to the next level, which helps the user to utilize their investment in an economic manner. If soil nutrients sensors can be installed, the system can be modified to supply fertilizers to the garden precisely. This system saves manpower and efficiently utilizes the water resources available, ultimately leading to more profits. The feedback provided by the system will improve the implementation of gardening process. We have also attached the video demonstration links of review 1, review 2 and review 3. Also the references of all the literature surveys has been given below. Thank you.